Oh, that's good. Mm. Let's see.
$80.
Hi everyone. I will ask to anybody who is not a speaker to mute your microphone, please. Okay, we will start just in just few seconds. So hi everyone. Today we will talk about FinRL and reinforcement learning in finance. Xiao-Yang will introduce all the speakers and welcome to everybody. Okay, Xiao-Yang,
Go.
it's your turn. Yes.
Okay.
Go.
Good evening, everyone, and welcome again to Paris Machine Learning Meetup. Great to see you all here. We have quite a few people this evening. Really happy. And today we'll be focusing on reinforcement learning in finance. We're going to focus on reinforcement learning in FinRL, an open source library designed to simplify RL application in trading. We will start with an introduction to reinforcement learning in finance and how FinRL helps streamline model development. Next, we will explore some exciting research showing how large language models can improve trading strategies and risk management. Finally, we will introduce FinRL Context 2025, a great opportunity to test your skills, compete, and gain recognition in the field. We're lucky to have an amazing lineup of speakers: Xiao-Yang Liu, Keyi Wang, Mostapha, Benhenda, Arnav, Colin Lin, and Sarah Huang, who will share their insights and expertise with us. I'm sorry if I did not pronounce all the names well. But now let's get started.
Hi everyone. I'm Keyi Wang, and today we will introduce FinRL, Financial Reinforcement Learning.
C'est tout vu avec tu peux dire Stéphane, on a vu avec Caillou que c'est bon, demain c'est nickel.
Sorry, excuse me? Okay, I will continue anyway. Here's the outline. First, we will introduce FinRL and go through the motivation, framework, key features, and FinRL contest in 2023, 24, and 25. Then I will invite Mostapha to introduce FinRL-DeepSeek. Finally, we will introduce FinRL contest 2025. Algorithm trading is playing an important role in financial markets, accounting for over 60% of the total trading volume in the US equity market. It relies on automated decision-making, which requires to make dynamic decisions, decide where to trade, what price, and what quality. And also, we need to trade in a highly complex financial markets. Uncertainty and rapid fluctuations in financial markets make decision-making extremely challenging. And we believe deep reinforcement learning, DRL, is particularly well suited for quantitative trading. So in DRL, it has two basic components. One is agents and the other is environment. The agent will interact with environment to learn from its past experience and optimize its strategy. And how can it help quant trading? So first, it solves dynamic and sequential decision-making problems, and it can also build a multi-factor model to trade automatically, including various market signals and risk factors. It also offers portfolio scalability and market model independence, meaning that this agent can adapt to different trading environments and market conditions. Here is a comparison between conventional machine learning approach and reinforcement learning in finance. So in conventional machine learning approach, they really involve multiple models such as alpha model, risk models, and portfolio construction models to perform a trading task. However, for reinforcement learning in finance, it only introduces a single DRL agent that learns optimal trading decisions directly from data. So in this way, it simplifies the workflow while adapting to dynamic market conditions. Therefore, we aim to automate the design pipeline of a DRL trading strategy. It requires to include 4 key steps: pre-process market data, build a trading environment, manage trading states, and backtest trading performance. To achieve this goal, FinRL follows 3 key principles. The first one is full-stack framework. FinRL provides a complete DRL framework that integrates the entire workflow, from data preprocessing to model training and evaluation. Secondly is customization. The framework is designed with modularity and extensibility, which allows users to customize trading tasks and their strategies. The third one is reproducibility and hands-on tutorial. FinRL offers tutorials and reproducible use cases, which makes it easier for users to learn, implement, and validate their strategies. Overall, FinRL is an open-source framework in financial DRL that provides efficiency, scalability, and accessibility. For efficiency, users can save time and computation by utilizing this automated pipeline. For scalability, with stable and customizable RL training, users can use FinRL in different market conditions and trading tasks. And accessibility, we provide hands-on tutorials to help newcomers to get on hands quickly. Here we show the entire automated trading process in FinRL. As we said before, there are 2 key components, agent and environment. In financial scenario, agent represents the investor or the trader who needs to take a trading action, and the environment represents the trading market. So it contains some market conditions such as price, balance, and some market indicators and so on. The state is the snapshot of a current market conditions. So when facing a state in the environment, the agent will make an action. For example, at this time, I decide to buy 100 shares of the Apple. Then the environment will receive this action, step into a new state, and calculate the reward. For example, after buying the 100 shares of Apple, the cash used to buy the 100 shares will be subtracted from the balance. And my holding of AAPL will increase by 100. The price will also be updated to the next trading snapshot. And the reward, which reflects the change in my portfolio value, will be calculated between these 2 states. So facing the new state and the reward, the trading action will continue to take a new action. This process will continue, and the agent will learn from its past trading experience to optimize the trading strategy. So in the FinRL trading process, there are 3 important components in the environment: state, action, and reward. So state reflects the current market conditions. This is the information that we need to know when making a trading decision. For example, we need to know our current account balance, the stock price, the equity price, and also we need to know holding shares. We can also include fundamental indicators, technical indicators, market sentiment, and so on. For example, we can use common market indicators like moving average, convergence, divergence, relative strength index, or any other alpha factors. Action is what the agent can do. It depends on the task. Very basic actions can be buy, sell, and hold, or we can also use short and long actions, or the action can be adjusting portfolio weights in portfolio allocation task. The reward is an incentive signal. For example, it can be the change of portfolio value. If my portfolio value goes up, I will be incentivized and learn that, okay, at this stage, taking this action I will get positive return. Then I will maximize my action. In contrast, if my portfolio goes down, the reward is negative, I may want to avoid making this action next time. So the trading agent will learn from this trading experience and this reward. With these three components, we can construct the trading environments for different markets and tasks. For example, we have environments for stock trading, crypto trading, and so on. And it can also be adapted to markets in different countries. We can also have environments for paper trading and live trading. Here, we will introduce the FinRL framework. It consists of 3 layers: application layer, agent layer, and environment layer. On the application layer, FinRL aims to provide hundreds of demonstrative trading tasks, serving as stepping stones. For example, we have demonstrations for stock trading, portfolio allocation, crypto trading, high-frequency trading, and so on. It also allows users to self-define tasks by defining state, action, and reward. On the agents layer, FinRL supports fine-tuned algorithms from FinRL libraries. For example, Elegant RL, RL Lib, Stable Baseline 3. It is in a plug-and-play manner so that users can easily change and plug different agents. On the environment layer, FinRL aims to wrap historical data and live trading APIs of hundreds of markets into training environments. It has a full pipeline for downloading and pre-processing datasets from over 30 data sources. Now, let's walk through an example of using FinRL to perform stock trading. So imagine we have 10,000 at the beginning of 2016, and we want to invest this capital into stock markets. In this case, we want to invest in all 30 stocks listed in the Dow Jones Index and use FinRL to develop our trading strategy. So the first question is that, how can we map stock trading into RL language? We can formulate this problem in the Markov decision process. So as we discussed before, we need to map the problem into the state, action, and reward. So the state is the current market situation perceived by the trader. So it includes the outside market conditions, such as the stock price, the technical indicators like moving averages, volatility, and momentum. And the action is what the agent can do. In this case, the agent can sell, buy, and hold the stock. The reward, as said before, is the incentive for the action. So we can use the change in portfolio value after taking an action. A profitable trade results in a positive reward, but a loss will lead to a negative reward. So after defining state, action, and reward, the agent can interact with the environment. We know that agent learns from environment and past trading experience. So how to design an environment specifically for stock trading? We can incorporate key market constraints to make the environment realistic. For example, we can include market liquidity, which ensures the agent can only trade stocks with sufficient volume, and non-negative balance, which prevents the agent from going into debt. Transaction costs, accounting for commission fees and slippage, and risk aversion, which encourage the agent to avoid market crashes and extreme loss. With these constraints in place, the agent interacts with the market, learns from past trading experience, and continuously improves its strategy. So here is the configuration of the environment. For the state, we will include 7 parts of the information. It includes the balance, the account balance, and the close price of the 30 stocks, and the amount of holding shares of the 30 stocks, and the technical indicators, including MACD, RSI, CCI, ADX. These are common market indicators. So wrapping all this information, we got the state space to be a 181 dimensional vector. And for the action, for each stock, the agent can buy, sell, or hold at most K shares. And for the 30 stocks, the action space will be 2K plus 1 to the power of 30. Then for the reward, it's the change of the portfolio value. the agent will learn how to maximize the positive change and minimize the negative change. Now we can set up our experiment. Firstly, we specify the training, validating, and testing period. Then we download the OHLCV data, which is open, high, low, close, and volume data from WRDS. After that, we can construct the environment based on the previous configuration, and then we train the agent. Finally, we will validate agent on the validation data, run our agent on trading data, and compare performance with baselines. Here we show the performance of DDPG agent. We have two baselines, the mean variance and Dow Jones Index. We can see that which achieved a cumulative return of 97.91%, which is much higher than the two baselines, and it also has a higher Sharpe ratio of 1.79. If you're interested, we welcome you to explore the code of this example. I will just briefly go over the important steps, and there are several differences because we have updated the code to use more recent data and more codes. I will stop sharing and reshare to the code. So the first step is to install required packages. FinRL Library is very easy to install. And the first step is to fetch the data. Because we want to invest in 30 stocks in the Dow Jones Index, so here we configure the tickers, and then we specify the training period and trading period. Then we can use the Yahoo downloader from FinRL Library to download the stock data. So it will look like this. And after that, we will pre-process our data. We can use the feature engineer from the FinRL library to pre-process data to add technical indicators. So it's easy to specify the parameters and specify the arguments. And here is the final data set. So as you can see, we added like about 10 technical indicators here, MACD, Bollinger Band, and other CCI, something like this. And then we can save the data. This is for data preparation. And after that, we will construct our environment and train the agent. So first we load the data, and then we specify the required configuration. For example, we have the initial amount. Here is 1 million. And we also need to specify the state space and the action space, the state space and action space. After that, we have our environment, and then we need to initialize our agent. We can directly use the DRL agent from FinRL library. So use the train model, this function, to train the model. Here is the log for the training process. After training, we can save this model. Below are more models like DDPG and PPO. They are more agents. Then finally, we can backtest the performance. So first, we need to load the trading data, and also we need to load the trained agents. After that, we need to construct a new environment for trading. So this time, we need to specify the configuration and also use the trade data. Here is the mean variance strategy, which is the baseline. And also here is the Dow Jones Index, another baseline. So after combining the backtesting results, we can plot the figure here. So this is basically the key steps in the code. I'm sharing my screen. Need to. Oh, it's here. Okay, so this is the code example. So you can run the code if you are interested, and link is provided here. Then I'd like to discuss some technical features for FinRL. So the first one is FinRL Ensemble. One of the key challenges in reinforcement learning is policy instability. The performance of RL policies can be highly sensitive to hyperparameters, unstable environments, and even random seeds. The agent can have unstable performance. To address this challenge, we leverage ensemble learning. So ensemble learning is a powerful technique in machine learning that combines the predictions of multiple models to improve overall performance. And in the context of FinRL, we use multiple RL agents, such as PPO, SAC, DDPG, trained on different environments. The ensemble approach aggregates their decisions using weighted averaging. Then we also use KL divergence in the objective function to help enforce diversity among agents. We also utilize massively parallel simulation. One of the biggest challenges in RL for trading is sampling efficiency. We know that financial markets are highly non-stationary and dynamic. Market conditions change unpredictably, so it requires extensive sampling to train RL agents effectively. It requires a large number of samples. So to address this challenge, FinRL utilizes a vectorized environment, which manages parallel sub-environments. So each sub-environment simulates its own market scenarios, including balance, price, holding shares, and so on. In this way, we can simulate trading on thousands of environments in parallel, and passively parallel simulation can enhance resource utilization and improve sampling speed. And as I introduced earlier, we also focus on hands-on tutorials and education. In the past 2 years, we have conducted 2 FinRL contests. They feature with different tasks in FinRL and large language models. FinRL Contest 2023 has data-centric stock trading, which focuses on data engineering. And the second task is real-time order execution, which is to construct a lightweight algorithm for order execution. And FinRL Contest 2024 has cryptocurrency trading with ensemble learning, which encourages participants to utilize ensemble learning and massively parallel simulation. The second task is LLM engineered signals with reinforcement learning from market feedback. So it aims to utilize market feedback to fine-tune the large model so that we can make it align with the financial markets. This year, we are also holding the FinRL Contest 2025, which we will introduce later. In addition, we also have FinRL tutorials with the mission of creating hundreds of user-friendly demos. It targets at students, researchers, and practitioners at all levels, from beginner to advanced scenarios. That's all for FinRL, and let me pass to Mostapha to talk about FinRL-DeepSeek.
Hello, so thank you everyone for being here. So I will share my screen. Second, share the screen.
Maybe, excuse me, Mostapha. There's just there's two questions in the chat. Maybe we can take just the 2 questions with a very short answer, and after it's to you. Is it okay for you, Mostapha?
Yeah, no problem.
Okay, so first question for you, for the previous speaker. I don't know what is data bento, but does it have adapter for data bento?
I think currently we mainly use Yahoo Finance to download data. For data bento, I think it's easy to wrap into the API into the environment. I'm not sure. We can check the FinRL meta for the 30 data sources, but I believe it's easy to add it if we don't have it.
Okay. Second question. How can the rewards be evaluated if the reward happens to be fluctuating? For instance, an action may produce a loss on the short term, but maybe a good investment if you wait sometimes?
Yeah, that's a good question. So actually, reward designing is actually a very key component in designing the environment. So if we only use the portfolio, the change of the portfolio value, then it may only reflect the short term. There can be some other ways to design the reward for long-term investment. So that actually depends on the task. But according to the experience and the experiments, if we want to perform the high frequency trading, or it requires actually large of extensive samples, and we can have thousands of environments for the sample, then at this time, a simple reward calculation is efficient to capture the reward signal. Hope this helped this question. Yeah.
Microphone is mute. Okay, are the strategies used by the agents after training like black box, or can they be explained rawly with some principal components? Oh, very good question. It's
Are
about
the strategies
explainability.
training?
Explainability.
Yeah, that's a good question. So in deep reinforcement learning, for the agents, they use the algorithms. Actually, they are using the simple like neural network. For example, like 3 or 4 layers. This is the architecture, and they also have some different like architectures which has actor and critic networks. So we also need to design the loss function and the objective function. I think most black box for the explainability. That's a question that we can study more. Yeah.
Okay. Last one, a very specific question about Bloomberg Anywhere. I don't know if you know Bloomberg Anywhere, but if one has a Bloomberg Anywhere, can one adapt the GitHub code to use Bloomberg as a source for the market data? The connectivity FinRL with Bloomberg Anywhere. Is this possible?
I think our FinRL library, actually it has 3 layer and it's in a plug and play manner. So you can prepare your own data yourself, for example, by using Bloomberg. After you get the data ready, it's easy to load the data, directly load the data into the environment. So it's actually plug and play for the data, environments, and agents. Users can change each components by themselves.
Okay, last question for about myself. In which frequency do you have the best results? High frequency, mid frequency, or low frequency? Which one is the best in your backtest?
Oh, sorry, could you repeat? I cannot find it in the chat. Which one?
No, it's my question, and
Yes,
I
I'm
didn't
sorry.
write it in the chat.
Yes.
Which frequency, which trading frequency is the best? Is this high frequency trading, mid intraday frequency trading, or daily frequency, monthly frequency, yearly frequency, and so on? Which one is the best frequency in your backtest? Did you backtest this or no?
For stock trading, actually we support daily. I think the most frequency we use is daily, minute level and second level. So for the stock trading, we mainly used daily level to trade for 30 stocks, and for the cryptocurrency, we mainly use the second level for LOB data in our contest.
Okay. Okay, very good. So Thanks to you. And now it's Mostapha. It's your turn. Okay, very good.
Okay, so
Thank you. Yes.
I will share my screen again. So can everyone see the slides?
Yes.
Okay, it's perfect. So I'm going to talk about FinRL-DeepSeek. So that's a way to infuse LLM and into risk-sensitive reinforcement learning. So the code and the data are available on GitHub. So I will briefly recall, because Keyi already speak a lot about this, like reinforcement learning. So basically, we have an agent that takes action in an environment, and that gets a reward as a result of this action, and that moves into another state as a consequence from this. And so in trading, let's say the mainstream approach in RL for trading. So the environment is the daily stock prices and price-derived indicators, like price-derived features, such as Bollinger Bands and other stuff like this. The agent is like the RL model, and the action is buying, selling, or holding stocks. And the reward is the daily profit and loss. And the state is the portfolio of all the assets under management. So that's, let's say, the basic setup in reinforcement learning, but the limits of this is that the limited use of alternative data sources, for example, the financial news, because the price don't fluctuate as random, they fluctuate as a result of what happens in the environment. And we have also risk management that is rarely considered, and it's a very important thing for like portfolio managers. Like their main task, their main mandate is not to lose too much money, especially in difficult market solutions. And what is the solution that I propose is a hybrid reinforcement learning and large language model agent, which relies on LLM-generated trading recommendations, LLM-generated risk assessment, and an integration of risk-sensitive reinforcement learning algorithm, which is called conditional variance at risk PPO. So that's the setting here. So the environment in this LLM setting is stock prices, but also LLM process stock news. And there are two different LLM signals. So from the same news, so there is recommendations. So you ask the LLM, do you recommend to buy these stocks after reading this article? But you also ask a risk assessment. So you introduce two different prompts to the same piece of news. So that's the new thing in this paper. So I will quickly recall what is proximal policy optimization reinforcement learning algorithm. So this is now, let's say, the most mainstream reinforcement learning algorithm. It was developed by OpenAI in 2017, and it's a kind of simplification of the previous algorithm. So there is the reward function, so it's like a loss function. I will not detail all the formula. So what I will more insist is on the epsilon. So basically, there is a clipped objective. So the idea is that the loss is around 1, but it cannot move too far from 1. So if the new policy diverges too much from the old one, there is a clipping that happens. And that's the main thing, because you want some stability in the training. So one of the main challenge in reinforcement learning is the stability, and how to hard code this stability is by making this clipping, so that there is this updates, the policy updates are step by step. So that's why it's called proximal policy, so that the new policy is near the old one. So epsilon in this trading environment is 0.7. So that's very important parameter. So this is a clipping range for trading environment. So it's much higher than environment in other reinforcement learning tasks, because trading is a very noisy environment. So that's why it's important to be very tolerant in the clipping, so have a quite large clipping. And then there is also another thing that is not even mentioned in the most videos that you will read on YouTube about proximal policy, is also the chiral divergence. So chiral divergence is a way to measure it's a way to have a distance. So it's not exactly a distance, but it's almost a distance between policies. And the PPO, it stabilizes this policy range by also asking the new policy not to be too far from the old one in terms of chiral divergence. and with epsilon prime, which is I calculated, like I tried a lot of different parameters, and I found 0.35. So what is very important is that both the constraint pair in tandem. So if you make one epsilon too big, then the epsilon prime, you have problem, and so on. So you have to optimize them jointly for effective learning. So that's a small introduction to PPO for trading, and then CVAR PPO. So this is, as you can see, there is a new term, lambda. So can everyone see the formula? There is a lambda 1 over alpha, etc. So this is an updated objective function. So to integrate the risk level, and the lambda is what is called Lagrange multiplier. So that's a way to enforce the constraints. So I will not detail everything, but what is important to know is that we take into account the conditional value at risk loss beyond some threshold. So that's this d of p of theta is very important. So why I show you this formula, the goal is not to get into the details, just to have a quick overview. Because when we input the LLM, there are two ways to input it. So there is, so as I tell you, there is trading recommendation and risk assessments. And we get from this STI and RTI. So for action input, the action, so when you have the trading, the agent takes some action like buying, selling, or holding. And this idea is to modulate this action from the trading recommendation. So if ST equals 1, no modulation. It's just LLM is neutral. But then the idea is to have it slightly higher than 1 or slightly lower than 1 to have this modulation by the LLM, so that the trading is perturbed by the LLM. So that's this idea to modulate the action by the trading recommendation. And then what is, I think, more interesting is to have this risk input. So in the when we input this the risk assessment, so the risk assessment, so it's kind of the same as the action. So if the risk is neutral, so if the assessment is neutral, the RT is equals to 1, and so the DP is so the DP that you see here is not perturbed. But then if we introduce this assessment, so stock by stock, and then we average them by the weights, by portfolio weights, so we get the overall risk assessment of the portfolio. And then if we injected it, we get that this objective function is slightly modified here of the D of P of theta that becomes DLLM. And so we get this input of the risk here that slightly modifies. And so then the agents have a slightly different perception, a slightly different reward based on the risk assessment by the LLM, so which is DeepSeek in this case. So that's basically these two modifications. So that's how the algorithm is modified. Now I will talk about the data pipeline. So I took NASDAQ 100. So that's a very famous stock index with training period from 2013 to 2018 and trading period for 2019-2023. And what is the data set? So there is a ready-made data set that is from last year. So this is the FNSP ID data set of 15 million news articles about NASDAQ stocks since 2099. So that's a very big data set. And because of the cost, because as you might imagine, this API is costly and it's just a proof of concept, I just kept 2 million articles. But if you, of course, if you have time, because we have this FinRL contest, so you can use all the news, you can try something more. Of course, you are welcome to do more with bigger data set, because of course in the experiment, the bigger data, the better. So the more data you have, the longer trading period, the best performance you have. And that's why it's, but also the higher computation you need, the higher RAM is needed. So the LLM, so I use DeepSeek v3. So it's not the DeepSeek R1, it's the one that was previous. And I also tried with Llama and with Qwen, but they underperformed, and Qwen was updated before I had time to do it. And so what is the performance? Because it's all about performance. The trading is about money, money, money. So performance, if we look, so the NASDAQ, maybe you cannot see, but the NASDAQ is in purple. So this is the reference index. So when you just do nothing, you just buy ETF. And then the PPO, so the plain PPO, you can see that PPO looks like better in the bull regime. So until 2022, bull regime, so you see it's better, but then it falls, like completely collapse when you enter into bear regime. And then when you get back to the, which is the year basically 2022. And then when we get back into the bull regime, so bull means NASDAQ is up, bear means NASDAQ is down. And then you can see in bull regime, it gets better. And it's very important to manage to look performance in bear regime, because that's where where you look for active management. Like when you have money and you want to invest in stock market, if you are in bull regime, you are already happy with NASDAQ going up. But when you are in bear regime, that's where you are looking for an active trading, and where you go to hedge fund or you start trading yourself, this kind of things. Like active, because ETF is like passive investment, but the value of these algorithms are active, and active is usually in bear market, because that's where you feel like you cannot just sleep and let your portfolio. You really want management. And here you can see that the CPPO DeepSeek performs better in the bear regime. So it's still not so well, but it still performs better than the purple line, and better, so what is the most important, but also better than the PPO with only market price data. So that shows the value of the news, because usually when you are in a bear regime, it means that something is happening in the news. Like now, for example, we enter in bear market because Trump wants to do some tariffs. So this is bear regime. And so the conclusion, but that of course I invite you to confirm by yourself, bull market PPO is better, but bear market DeepSeek, CPPO DeepSeek is better. And of course, what would be interesting is to combine both and do some things that is like at the top of the game in the bull market and in the bear market. So this is still work in progress. And of course, if you participate in the FinRL DeepSeek competition, you are welcome to try this. That could be a very great submission. And then maybe I will go very quickly, but what is the impact of this LLM infusion? So because you can see there are two ways to introduce this LLM. So for PPO, you can see that actually it makes it worse. So it was a very bad idea to manipulate the actions. But on the other hand, by manipulating the reward, it performs much better. So you can see that NASDAQ is like purple, but we have like orange is like even better, and so on. On the others, like the more you introduce higher impact of the LLM, the better you get in this way. And of course, you are invited in this competition to try even more parameters. So there is 0.1, 1, 10%. Maybe you can try 20%, 30%, see what happens. And so that was the conclusion. So maybe I will say a little word about my setting, because I know a lot of people in this FinRL, they don't have money, they don't have cluster, they don't have cloud. How to do? This is a zero budget computing project. So you can do it like LLM. How do you get free LLM? You get them like I use free trial. So it's from Deep Infra, so through F6S. So if you go there, you will find Deep Infra and you get free credits. And for CPO, it's very important to use more than 100 gigabytes RAM. So I used 128, and I use it for free from Scaleway, $100. So I used some this, so that's why I think they deserve credits here, especially that the other clouds didn't work. So it's good to know which one works. So of course, future work, there is so much to do. So that's why I'm very enthusiastic about this FinRL competition. So improve the data quality. So because if you look at the news articles, a lot of them are useless. And so they add more noise. and also frequency. So that was the question of Frank. Well, what is the right frequency? That's also a good question, how to optimize the frequency. And also the latency, I think very important latency, because nowadays the news, the legacy news are not good latency. Now it's all about Twitter for stocks, Telegram for crypto, Discord, all these kind of like social media news signals, and they should be taken into account. And you are of course invited to try them. And of course, I think also very important to do, and I'm sure someone will do it if it's not already done, to use the training method of DeepSeek, like the reasoning models, to adapt them to the trading instead of using LLM API. But that requires more work and probably more computing. And then, of course, deploy this on live market. If you use it in live market, first, please let us know your performance, your portfolio, etc. So that's all for the presentation. And of course, you are welcome to participate either in the competition or just in the GitHub. Thank you very much.
Okay, thanks, Mostapha. Very interesting. The mixture between LLM and reinforcement learning, I think it's a very permissive way of research. So you have two questions, and one of them is very difficult. We will start with the easy part. First question, to what extent does the reinforcement learning agent follow LLM trading recommendations?
That's a good question. I didn't look, but that would be interesting to monitor to see day by day. I didn't look, but you are welcome to look day by day. What is the recommendation and what is the action, and to log this data when the agent is like trading. So that would be interesting just to look at this. I mean, if you have time, that would. I didn't look at this, but that's a good question. Will the data action not are risky? Yes, it can, because the thing is, it doesn't. But as in terms of action, maybe I can answer this. At the end of the day, I guess that the agent didn't follow the trading recommendation so often, because the performance, if you look at the performance of when you introduce these recommendations, the performance is kind of degraded. So it means that when it follows this recommendation, it makes things worse because of the way this LLM was injected. It was injected in the actions, so if you remember. So I can answer that it does not very often follow the recommendations, but it more followed the risk assessment. It more often followed the risk assessment because of the way this LLM was injected in the agent. So the agent, of course, it can. It's just a way. This LLM is not like an imposition. It's just a way to shift a bit either the actions or the reward. So it's not an imposition. It's just a way to shift a bit. So it can happen. Maybe does it allow the reliability of LLM? Yes, it would be interesting. Of course, that would be very interesting to do. I didn't have time to do all this. So if you have time to do it, to write a report about this, that would be very interesting. And we can have a follow-up call on this if you have some information about this.
About what?
About all these questions, like to what extent the agent follows the recommendation, to what extent it follows the risk, and yes, to analyze the reliability of the LLM. So to compare this with how the market moves. So that would be interesting to look at. And there is a notebook. So good question. There is a notebook, a collab notebook, where you can, if you modify this notebook, you can log this information and add it into the evaluation. So that's something possible from the collab notebook.
Okay, we will share. You will share with us the notebook collab, and we will share with in the YouTube channel. Yes. Okay, because for the 2 million randomly selected items, the articles they are randomly selected in yes.
Just randomly
in the time. Yes. Not randomly?
Yeah, just randomly without any.
Just randomly. Okay.
Yes, because of
okay.
yes.
Okay, there is a serious question. In fact, I don't know what to think about it. The question is, there is a look ahead bias because the LLM, according to this guy, Vincent, the LLM knows what happens until it cut off periods. So this includes most of the backtesting periods. What do you think about it, Mostapha?
Well, I think it does not. That's a good question. That would be nice to see, to take a custom LLM and compare it. But yes, that would be. But that's always the problem with backtesting. You know, backtesting is always you can always introduce like look ahead biases. So that's why it's always better to assess it, to have a forward experiment. So to take an LLM and that look at, have a prospective studies, not a retrospective, because backtesting is a retrospective study. So it's always better to have a prospective study where you can look at the future. So you can take an old LLM with some cutoff and do it. So that would be interesting to do. But my personal opinion still is I'm not sure if it affects so much because the LLM, there is a prompt and the prompt says to evaluate just the article. So the prompt, you can look at the prompt and say, look at this article. What do you think? Should I buy? Should I sell? What is the recommendation? So I don't think that the LLM will look deep into the history of the NASDAQ and to be biased. So I don't think it's a big bias. It's possible, and there is a way to ensure it by doing a prospective studies, but still, I'm not sure that it is significant.
Of course, according to me, I'm not a hyper specialist of LLM, but according to me, it will be very difficult to prove yes or to prove no about the look ahead bias until the LLM will explain or is able to explain or is able to have a feedback about its decision because it's a very huge black box, and the only way to prove maybe it can be to have a real trading in real time and to prove that it's okay and not only a backtest, according to me. But if someone has a different opinion, it can okay. So Mostapha, okay. I think we are done with the questions, so we can move to the last part of the meetup, the FinRL contest. Okay.
Yeah, thanks. Now I want to introduce our FinRL contest 2025, and I will invite our task leaders to discuss each task. So as I talked before, financial reinforcement learning is an interdisciplinary field that applies reinforcement learning in financial tasks. And large language models bring advanced natural language understanding and processing to finance. So it drives open finance, which can provide affordable and scalable solutions for customers to make intelligent decisions, and create personalized financial search and robo-advisors. So the integration of RL and large models is becoming more and more popular for developing AI models that can learn, adapt, and reason in dynamic environments. So our contest aims to foster innovative ideas and approaches in the application of DRL and other machine learning methods in finance, and we aim to promote open finance. This year, we bring new features to our contest. First is FinRL-DeepSeek, just as Mostapha introduced, and second is FinRL AlphaSeek. Factors play a critical role in driving trading decisions. and which enables traders to design efficient data-driven strategies. And the third feature is Open FinRL Leaderboard. It's an open platform to evaluate large models' performance on different financial tasks. And here lists our important dates. Now I will pass to Mostapha to introduce task 1.
Yes, so very briefly, so task 1, basically this is the follow-up of the presentation. So you can see like a lot of you ask questions, why not this, why not that? That's a perfect topic for the task. So that's exactly what is the task about, to refine the model, to explore the edge case, etc. So that's, and then the goal is of course to then at the end to improve this agent, to have a much more powerful agent. So I think that's enough. I think we can maybe let other task managers to speak.
Yeah, let's pass to Arnav.
Yeah, hello everyone. I'm Arnav, and I'm on the technical committee for task 2, which is FinRL-DeepSeek for crypto trading. So a bit of context, when we look at crypto markets in comparison to the traditional market, they offer some unique opportunities and challenges for algo trading. Crypto markets exhibit extreme volatility, and they run continuously, which goes well beyond the public market hours and even after hours. So this continuous operation makes them really well suited for RL approaches, which can effectively adapt to changing market conditions and make dynamic trading decisions. Of course, RL comes with its own set of challenges and sort of 2 key hurdles we've identified, which include the mining and obtaining good factors. So a factor is an input variable that influences trading decisions. Think price momentum or volatility patterns. Finding which patterns predict market movements is essential for developing a good strategy. And the second hurdle is policy instability. So Keyi and Mostapha touched on this a little bit. And in the context of algo trading, a policy refers to the strategy that determines whether to buy, sell, or hold an asset. And these policies often struggle to converge to optimal solutions, which results in inconsistent performance. So for this task, we've released a 2-stage baseline that leverages factor mining and ensemble learning techniques. And we also encourage the development of robust trading agents that make use of these stages, and also massively parallel simulations to overcome the sampling limitations. Awesome. And as a part of the Star Kit, we've also released a Bitcoin limit order book dataset at 1-second intervals. This provides really great high-resolution market information. And participants can also leverage data sources from the FinRL meta framework. This integrates over 30 different data sources through a standardized financial data engineering pipeline. For example, you can use Y Finance or any other available API. I know Alpha Llama and a couple others are out there. And then for trading agent architecture, Elegant RL provides an implementation of 10 different commonly used deep RL algorithms, for example, PPO or DDPG. And this allows a comparison across different approaches for the ensemble learning component of the challenge. And we evaluate models using 3 key financial metrics: cumulative return, Sharpe ratio, which evaluates the performance, and maximum drawdown, which evaluates the difference from the TROW to the most maximum loss. And the final score will be determined by averaging the rankings across these 3 metrics. So we really look forward to seeing what optimizations and agents the community develops. Thank you.
Yes, now let's pass to Colin.
Hi, this is Colin. So the Open Financial LLM Leaderboard serves as an open platform for the financial community to benchmark FinLLMs. And we can see from this picture that leaderboard workflow connects 3 core components. The leaderboard itself, it contains financial task and model evaluation framework. The second is demos. So for the leaderboard, we have a demo hosted on Hugging Face, and we accept contributions from academia, open source community, and financial industries. So for the purpose of long-term maintenance, we would like to foster a collaborative open ecosystem. And eventually, we will be able to claim what models are ready to use on the financial industries. Next slide, please. So currently in the leaderboard, we divide our datasets into categories. So these categories covers the most common scenarios in the financial sectors. So we have information extraction, textual analysis, question answering. So these can have some tasks like reading from a financial documents and answering different questions. And then we have text generation, risk management, forecasting, decision making. So all of these are very useful in the financial area for industries to apply the LLM in their actual use case. So next slide, please. This is our Hugging Face demo. In the middle is a table displaying the model score of different tasks. And by default, we are displaying the average of each task categories. And the bottom right is where you select task to be displayed on the table. And the table will dynamically update based on the selected settings. Next slide, please. So for this task, we would like to encourage teams to learn about the Open FinLLM leaderboard and compete for better performing models that can be shown on the leaderboard. And the final score of the model is the average of all tasks. We use 40 tasks on this leaderboard across different categories, and metrics includes F1 accuracy, entity F1, exact match accuracy, BERT score, BART score, and so on. There's a lot. So more details can be found in the link below. This is it for task 3.
Yeah, now let's pass to Sarah.
Hi, I'm Sarah. I'm the task leader for Task 4, Digital Regulatory Reporting. Regulatory reporting requirements have many variations and often involve extensive manual work, are very time-consuming, and could easily lead to errors. The ESA-DRR significantly reduces the time, resources, and costs needed because it automates and standardizes the regulatory reporting process. Task 4 aims to challenge the community to explore the strengths and limitations of LLMs in the below 3 domains and contribute a new task to the Open FinLLM leaderboard. The CDM is a machine-oriented model for managing the lifecycle of financial products and transactions. MOF evaluates and classifies the completeness and openness of machine learning models. We also encourage participants to explore reinforcement learning fine-tuning solutions. XBRL is a standard for electronic communication of business and financial data, like the SEC filings, but often has a high error rate in the filing process. We developed and upgraded the question dataset for these 3 domains. We'll provide the data sources so that participants can collect the data themselves, and participants are expected to train and fine-tune their LLMs to perform tasks in these 3 domains. Here are our benchmark data sets of CDM, XBRL, and MOF with corresponding data category, size, metrics, and source. So CDM task evaluates the capability of large language models to accurately interpret and respond to questions related to the CDM framework, including its structure, use cases, and implementation. The XBRL task assesses the ability of LLMs to retrieve and interpret XBRL filings. The model openness framework has 3 tasks, which are the license abbreviations, license OSI approval, and question answering. In the final score will be the average score, which are the fact score and accuracy of all tasks.
Yeah, thanks so much. To help participants get on hands quickly, we also provide abundant resources for education purpose. More specifically, we provide documentation for all of these projects so that they can learn more details about each project and task. And we also provide some code and demos in the GitHub. For evaluation, we adopt quantitative and qualitative approaches. The model evaluation has been discussed earlier. So for qualitative approach, Each team will submit a report, and we assign a group of reviewers to assess their paper from different aspects. And the final score is the 60% model evaluation and 40% qualitative evaluation. Winners will be invited to attend the conference and present their work. We welcome students, researchers, and engineers who are passionate about finance and machine learning to participate in the contest and contribute to open finance using state-of-the-art technologies. Yeah, that's all for today's presentation. Thank you.
Thank you. Oh, I asked one last question, but it was already replied in the chat. But I can still read it out. So the question is it possible that reinforcement policy can hardly have stability due to the high variance and non-stationary nature of the financial market? And Arnav answered that it's definitely possible. And it comes down to the design of the environment and the reward model. Thanks for the reply. And I don't think there are other questions.
It's a very interesting question. It is a very interesting question.
And yeah, another approach to addressing the policy stability is that we can use ensemble learning to combine different agent components.
Okay.
Yes.
It's a natural way to to handle this problem. Yes. And according to me, there's certainly variability in the time because at sometimes the financial market there's a very clear trend, and after it can be very more noisy, and maybe there's a kind of variability inside the variability. I don't know if it's very clear, but probably. Okay, so very good. No question. Okay, I think we are done. And
I have one last word, probably. I personally find the contest very interesting, and if some of the audience are interested to participate, you can even look for collaborators in our meetup group, like publishing a notice, like I'm looking for someone who can work with the same task with me. I think that's one of the goal of our meetup group.
Thank you so much.
Okay, yes, very nice. Okay, thanks you all for joining. Hope you gain valuable insight into reinforcement learning in finance, and we look forward to seeing your innovations in the FinRL contest. And it can be very nice if you come back after the contest to have a follow-up to explain what was new, what did you gain, earn, and learn about all the different contributions. Yes, it can be very, very nice. What do you think about it, Mostapha? Yes, it can be. Yes,
that's a good idea. That's a good idea. I think yes, to make a follow-up after the competition and see what we can do next.
Okay, very nice. At the end of April or maybe something.
It's in May. It will be in May.
In May, yes.
There is a conference where there is a winner, and then we can after the conference.
Yes, the conference. And where is the conference, Mostapha?
In New York City.
New York City. Okay. Yes. Yes. You invite the winner of the contest. Yes. Okay. Did you already mention it? Or yes, maybe you can repeat it. Okay, once again. To motivate.
Yes, you can repeat. The winner of the conference gets go to New York City to present at the conference. Yes, at the conference.
Yeah, very nice. Okay.
Yeah.
Okay. So
And you confirm that all the
yes.
training stuff, we can have free access, right?
Yes,
We will
we
pay
have
nothing
published.
to the training. Okay.
We've published the starter kits for the code, but for any computation resources, you may need to find your way to access them. Yeah.
Okay.
Okay.
Thank
Very
you.
nice. Okay. So thanks everybody, and see you next time. And once again, thanks for all the speakers. And it was a very challenging meetup because there was a lot of speakers. Maybe we have hit the record of the number of different speakers, but we have perfectly respect the constraint time we have because it's 8 p.m. and it's very completely perfect. Okay, so thanks to everyone and see you next time.
See you. Bye bye.
Yes, thanks again.